Hey, welcome back. I'm going to continue with section 2.4. We just finished just describing the different kinds of symmetries. We have x-axis symmetry, y-axis symmetry, and origin symmetry. And the way to test it is to look for mirror points. Mirror points occur across the axis let's go back to a y-axis symmetry. Y-axis symmetric points, if you negate the x-coordinate, you end up at the same point on the graph on the other side. If you negate the y-coordinate, you end up with a point for x-axis symmetry, like 710. If you negate just the y-coordinate, you end up on the graph again. See the blue line? You're on the graph again. This is not a function. This is a relation because it doesn't satisfy the vertical line test. All right, that was neither. And then we ran into a origin symmetric. With the origin symmetric, if you negate both coordinates, you end up back on the graph. And we could see that with those 2 points. Now, that's how we're going to test these things algebraically. That's what this next section is how to test it algebraically. So here's our relation, 5x minus 5y equals 0. Now, we could write this as a function, but it's unnecessary as far as the testing it algebraically. Now, what we're going to do to test for x-axis symmetry, the test for x-axis symmetry, you replace the y with a negative y, and you see if it's still on, if the equation remains the same. For y-axis symmetry, you replace the x with a negative x, and you see if the equation stays the same. And then for origin, you replace both x with negative x and y with negative y, and see if the equation stays the same. Let me show you what I mean. So 5x minus 5y equals 0. So if we replace the y with a negative y, then it does actually change the equation. It becomes 5x plus 5y, and that's so that this is not y-axis symmetric. So if we replace the x with a negative x, then we have a problem there as well. It changes that to a negative 5x minus 5y, and so that is not x-axis symmetric either. But if we replace both, then we actually get something interesting here. That becomes 5 negative x. This is negative y. Now, it doesn't look like it's the same initially, but if you multiply through by a negative, we end up 5x minus 5y, which is the same as the original. So we could say that this is symmetric about the origin. It's not obvious just by looking at it, but if you change both the x and the y by a negative, you're back to the original equation. Let's do one other, and then we'll determine whether the graph is symmetric with respect to x-axis, y-axis, origin. So we're going to do it by testing. Now notice how you have a square on both the 4x on the x and the y. So this is going to be all three. Because if you replace x with negative x, there's no change. If you replace y with negative y, there's no change. If you replace x with negative x and y with negative y, there's no change. So we get x-axis, we get y-axis, and we get both. And we get origin, and we get origin as well. We get all three with this one. And it's because if you replace x with negative x or y with negative y, there is no change in it at all. Let's skip to... well, I think that's all we'll do for now, and we'll do some more a little bit later. Thanks.